Hello, this is meant to be a quick rundown of how to use CodingBat. There's a lot of videos out there that talk about individual problems that they've solved on CodingBat, but this is just, if you've never used CodingBat before, it's a quick overview of how to start using it. One of the first things to do is to actually go to codingbat.com and then choose whether you want to solve problems in Java or Python. This is going to focus on solving Java problems, but you could use Python as well. It's a matter of which kinds of problems and which language you prefer to work in. One of the first things to do is to set up an account, because if you have an account set up, then all your work is saved, and you can share that work with your instructor if your instructor wants that. So to start, just create an account. I'm going to create a fake account here. Let's see here, fake account. And all right, so now we have an account, and you can see that the problems on Java and CodingBat are kind of broken up into sections. And so this is a great place to go if you want to develop skills in a certain area. So for example, if you are learning about strings and you want to learn more and get some practice with strings, you can go to the string1 methods or the string2 methods, which use loops, or the string3 methods, which use multiple loops, nested loops, things like that. Whatever it is you want to practice. If you want to practice arrays or recursion or other kinds of problems, any of these areas that you pick, you can click and you'll see, I don't know, there's probably about 30 or 40 problems here that you could solve. I'm going to walk through how you solve problems. This, using CodingBat, assumes that you have seen and worked with methods before, because every single problem is a short method that you have to write. You're given a description of a method, and then you have to write the code for that method, and then you test your code to see if it works against a lot of test cases. So it does assume that you know how to work with methods. I'll talk a little bit about how to read the screen. So if you've seen methods before, this should feel pretty familiar. If you've never seen methods before, you still might get the hang of it, but it helps to be familiar with methods, parameters, return types, things like that. So let's pick something from Logic 1. And what's a good one in here to start with? Let's try Love 6. Each of these problems is set up the same way. It begins with a description of the problem, followed by some test cases, followed by the place where you write your code. And after you write your code, you click Go to test your code. So here's the problem. It says the number 6 is a truly great number. Given two int values, a and b, return true if either one is 6, or if their sum or difference is 6. And then here's a note. It says, note that the function math.abs, or the absolute value, computes the absolute value of a number. You don't need that necessarily, but sometimes these hints are there because it may save you a line of code, or it may be the right way to go. When you look at the next part, it gives you some test cases, usually just a few test cases. So it shows you that if the two input numbers, you go back and we see that there's two int values. If the two int values are 6 and 4, this method should return true. And why is that? It says you should return true if either one is 6. This next one, 4, 5, returns false. Neither one of them is 6, nor is their sum or their difference 6. But if you look at the last one, neither one of those is 6, but it returns a sum of, or a result of true, because the sum is 6. So we want to return true if either of the numbers is 6, or if the sum of the numbers is 6, or if the difference is 6. And difference could go either way, right? It could be a minus b could be 6, or b minus a is 6. None of these test cases show that, but there's no, when you see something like the difference is 6, it does not imply that it has to be a minus b. It could be b minus a. The difference would still be considered to be 6. So there's a lot of different ways you can solve these. I encourage you, if you solve the problem, to then step back and look to see if you can find another way to solve it. When you click Go, it will test your code against a number of test cases. You could click Go right now and it's going to fail all test cases. It's not even going to run because it says it's missing a return statement. So when you look at the header of the method, we see that this method is supposed to return a Boolean. And so if we don't have a return statement in there that returns either true or false, then it's not going to compile and you're going to get a missing return statement. So notice that this is a compile problem. It's not that your code ran and failed on some test cases. It means your code will not compile, will not run against any test cases. So we could try a naive solution to this, an incorrect solution to this, just so we can see how it works. We say if given two int values, return true if either one is 6. So let's say we write if, oh, and notice, sorry, I should back up here. There are two parameters here. The parameters are provided. You shouldn't change the header of the method. This is a method that has to return a Boolean, and it has two parameters. Here they're named A and B. So you have to work with the A and B, and you're essentially writing code that uses A and B to derive an answer, and then you return that answer as, in this case, a Boolean. So let's try if A is equal to 6, return true. Now, as I've written it, this code still will not compile. I'm going to get the same error, missing a return statement, because my only return statement is behind an if statement, and if that one is false, then nothing would be returned. And so we still get this compile problem, missing return statement in line 6. So let's say else return false. Now this is not the correct solution, but it should compile because now either way we're returning a Boolean value. The problem is it's only checking if the first number is 6. And so we can run it and see what test cases look like. In this case, you can go through test cases, and let's take a look at how to read these test cases. This tells me that one of the test cases was 6 and 4. It tested my code against 6 and 4, and the expected value was true. That's because 6 is 6. One of the numbers was 6, and so the expected value is true, and this true here is what my code returned. And since it expected true and the run was true, that's good, and it's green. Green means it passed that test case. You can see that it passed this test case. Neither one of those is 6, and the sum is 9, and the difference is 1 or -1, and so that should return false. My code returns false, so it's okay. Now we look, and here's our first fail. We get red indicating that we failed this test case. Let's look at the numbers. The numbers are 1 and 5, which should return true because the sum is 6. But my code returns false because I was only checking to see if A is 6. So that means I need to fix the code so that it's checking for the sum being 6. And you can find other instances. Here's one where I failed. Here the difference between 1 and 7 is 6. So it should return true, but my code returns false. Because again, I'm only getting it right in cases where the first number is 6 or where neither is 6 and the sum's not 6 and the difference isn't 6. So my code's bad. I need to fix my code. I could fix this with additional if statements. We could say else if A is equal, let's say B is equal to 6, return true. And we can check for the sum, else if A plus B is equal to 6, return true. And then we could check the difference, else if A minus B is equal to 6, return true, else return false. Now is this going to work? Not exactly. It fails. It fails in at least one test case. Notice, by the way, that there are other test cases that I can't see. So I can't write my code for particular test cases because I can't see all the test cases. But let's see, why did I fail this one? I failed because the difference is 6, but I only checked the difference a minus b is equal to 6. I need to also check if b minus a is equal to 6. So, okay, let's write this as one more else if b minus a is equal to 6. This should work, and then we'll take a look at ways to maybe make this code more concise. This is a reasonable solution. It's checking all of the possibilities. So when I run it, it should pass this test case now because I'm checking if b minus a is equal to 6. And it's already passing the others. So let's go ahead and click go. And we see that I get green all the way down. I got a green check mark. Green check mark means that problem is solved. On CodingBat, your problems are either solved or not solved. If they only pass some of the test cases, there's no partial points that you get. It's either you get a green check mark because you passed all the tests, or you don't get a green check mark because at least one of the tests failed. So here is a workable solution, or a reasonable solution, that checks as 1, 2, 3, 4, 5 different tests for when to return true. If you're familiar with working with Boolean expressions, then you know you could check multiple expressions in one set of parentheses. So let's change this a little bit and check to see if a is equal to 6 or b is equal to 6. And that means we no longer need this. And we could change the checking the differences to check both differences. So if a minus b is equal to 6 or b minus a is equal to 6, return true. That's a little more concise, and it combines some things that are nice to combine. It's checking the a or the b, it's checking the sum, and it's checking the difference in both directions. We run it again, and there it is. It still works. By the way, if you were to sign out of or just exit CodingBat and then come back, your code is still here for all the problems that you've solved, whether you've solved them incorrectly or not. As long as you click go, your code is saved so that you can return to it later. And if you want to try a new solution, there's a place down here where you can tell it to forget your code so that you can go back and solve it again if you would like. So one of the things that there was a hint in here, you may remember, that math.abs will compute the absolute value of a number. Where can I use that? Well, here, instead of having to check a minus b and b minus a, I could just check if the absolute value of the difference is 6. So if a minus b is 6, or if it's negative 6, that would be another way to write this, right? If a minus b equals 6 or a minus b equals negative 6. And that also works. But the absolute value can work here as well. So I could have asked if math.abs of a minus b is equal to 6. And still works. Now it's using the absolute value. You didn't have to. It was fine without it. And in some ways, not calling a method is sometimes, in some situations, considered better than having to call an external method. Can this be simplified more? Sure, you could make this one long if statement. So we could move the sum up to here and the difference up to here. And then we don't need these two separate checks. So now we're asking in one long Boolean expression if a or b or the sum or the difference are equal to 6. And we still get this to work. And there's one more solution for those who like to try to solve things in the least amount of code possible. You could, in a case where you're returning a Boolean, you can think about it this way. If this Boolean expression is true, then I'm going to return true. And if this Boolean expression is false, then I'm going to return false. In other words, whatever this Boolean expression is, true or false, that's what I'm going to return. I could just return the value of that Boolean expression. And if you take a look at that, that should make some sense. Imagine if one of these four things was true, either the A or the B or the sum or the difference is 6. If one of those is true, then this entire Boolean expression is true. And so I will return that Boolean expression of true. Similarly, if all of these are false, then the entire Boolean expression will be false, and I will return false. So this does solve it. Sometimes it's nice to write your solutions as a simple return statement rather than an if or multiple if statements. So there's multiple solutions to the same problem, and once you've solved a problem on CodingBat, you can click on previous or next to work through the same section of problems. So if I click on next, it takes me to the next logic 1 problem in that section. I typically go back to the section, and you can see which problems you have solved and which problems you have not solved. Notice that some problems have an H, indicating that that problem will have a hint. So something to help you if you're having trouble solving the problem. Here's a problem about choosing whether or not deciding whether or not you're going to get a table at a restaurant, I believe. And then if you look, it gives a hint about the pattern that you might consider using to solve the problem. Let's see if we can find one more problem here to solve. Given a non-negative number, num, return true if num is within 2 of a multiple of 10. Note that a mod b is the remainder of dividing a by b, so 7 mod 5 is 2. So to find multiples of 10, well, let's see here. I want to know if num is within 2 of a multiple of 10. So one way to do this is to say if the number ends in 8 or 9 or 0 or 1 or 2, for example, 28 is within 2 of 30, 51 is within 2 of 50, but 64 is not within 2 because it ends in a 4. So it looks like a solution here would be to look at the last digit of the number and to see if it ends in 8, 9, 0, 1, or 2, then it is within 2 of a multiple of 10. Let's try that, and I'm going to deliberately make a mistake here with my solution because it's a common mistake that I've seen. We could say, let's see, so I want to handle the 8, 9 case. First, let's get the last digit of the number. So we'll store that in a variable. And num mod 10 is very useful for getting the last digit. Well, I don't think I need that comment. I called it last digit. But it does give you the last digit of any int value, of any positive int value. If you do it with a negative, you'll get a negative. You'll get the negative answer of the last digit. So for example, negative 17 mod 10 in Java is negative 7. But if we have the last digit, then we can ask if the last digit is 8 or 9. So we could ask if it's greater than or equal to 8. That would handle 8 or 9, right? Then return true. But also if it's 0, 1, or 2, and remember, last digit is just a single digit number, so it's enough to ask if it's greater than or equal to 8. That would be 8 or 9. So you could write if last digit is less than or, well, let's say less than or equal to 2, return true. And then you could say, but if it's anything else, you want to return false. So you could say if last digit is greater than 2 and less than 8, return false. The idea makes sense here. If it's at least 8, return true. If it's 2 or less, return true. And if it's anything in between those, return false. The problem here is this code is not going to compile. The logic makes sense, but it won't compile. Let's see here. It's telling me something about my curly braces. Missing or illegal start of type. So I made a mistake earlier than I thought I did. Oh, here it is. That's another common mistake, and I just made it. I have to ask if last digit is greater than 2 and last digit is less than 8. It's not enough to say last digit is greater than 2 and less than 8. I still have a problem here. The idea makes sense, but let's see here. Now it says missing return statement on line 13. Line 13 is probably the last line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's saying it got to line 13 and there was no return statement. And you might say, well, yes, there's 1, 2, 3 return statements. But the problem here is that every one of those return statements is behind an if statement. And in the event that all 3 of those ifs would test to be false, then none of the return statements would ever be hit. And so nothing would be returned. That's what the compiler is saying is a missing return statement. You want to make sure you have code where your return statements are not all hidden behind if statements. If all of them are behind if statements, your code will not compile. And so a more sensible solution would be to remove this last check, because the truth is, if a number is greater than or equal to 8 or less than or equal to 2, will return true. Anything else should return false, and that's what an else is for. And then this needs to be an else if. If you prefer nested, you could write this as nested, but if and then else if and then else should work here. And again, if you prefer a solution where there's a shortcut, by the way. The editor in CodingBat has some nice features, and one of them is you can comment out a bunch of code by just hitting Control/, and the highlighted code will be commented out. And hopefully, if I click it again, yeah, it returns. So I'm going to comment that out and see if I can write this as a one-liner again. So I'm happy if I should return true if the last digit is greater than or equal to 8 or less than or equal to 2. So I could say return last digit is less than or equal to 8, or last digit is greater than, did I do that right? No, I didn't. Greater than or equal to 8. Or is less than or equal to 2. That should work. Yeah, let's see here. Nope. What did I do wrong here? I said less than or equal to 2, and I typed greater than or equal to 2. But let's take a look at this. You can see where it's failing. Near 10 of 6. 6 is the input. That is not near 10, so the expected value is false, but my code is returning true. Because my code, the way I had it just now, was returning true as long as the last digit was greater than or equal to 2. So anything where the last digit, the only places where my code was coming out false were places where the last digit was 1 or 0, I believe. Yeah. So let's fix this to last digit is less than or equal to 2. And it works. And I haven't solved enough problems here to show you this yet, but if you solve, I think it's 5 problems, you will get a gold star. If you see a gold star and you're wondering, why do I have a gold star? It simply means that you have solved 5 more problems on the site. It doesn't mean that the code for that problem is better or worse than any other solution, but that's CodingBat. It will keep track of your work, and I encourage you, if you need to develop your skills, to just go back to CodingBat periodically and solve some problems. They're typically short. Some problems are trickier and might take a little while, but generally they're problems that can be solved in a few minutes each. The harder ones may take you an hour or so. Some you need to think about and walk away and come back later and think about them some more. But it's a good place to practice. I have seen some students of mine solve all the Java problems. I've had one student who solved all the Java problems on CodingBat and then went and taught himself Python so that he could solve all the Python CodingBat problems as well. So there's your bar. There's your challenge, is to see if you can solve all of these. But for now, have fun using the site and have a good day.